This video will present solutions to the VCE 2024 Mathematical Methods, Written Examination 2, Section B, Question 2. This question starts with a model for the temperature of a room that uses a piecewise function f of t. In Part A, we are asked to express the derivative f-t as a hybrid function. The differentiation of the two expressions that make up f of t is relatively straightforward. The t values associated with those two derivative expressions require a little care. It would be easy just to copy the information from f of t, but whilst the function is continuous at t equals a third, it is not differentiable at that point, as the approach to this point from the left and from the right has different gradients. And so this point should not be included in either interval for t. Part B of this question asks for the average rate of change of this model from t equals 0 to t equals a half. As a half is greater than a third, f of a half is equal to 22. Subtracting this from the function value at 0, which is 12, and dividing by a half takes 0, we get an average rate of change of 10 divided by a half, which is 20. In Part C, we move to a different model for the temperature of the room, which we are asked to differentiate in Part 1. As the function is a relatively simple one, this derivative can be found with or without a class pad. I'm going to use the main app of my class pad so that I have access to g of t and g-t for the remainder of the question. For my class pad calculations, I'm going to use x in place of t for ease and speed of entry. For C Part 2, we need to solve this derivative equal to 10. Choosing the Solve Numerically option, the solution, rounded to 3 decimal places as required, is 0.299. Part D asks when the two models for temperature are equal. As g of t is never equal to 22, because e to the power of negative 6t is never equal to 0, we just need to equate 12 plus 30t to g of t. As we are looking for a 2 decimal place answer between 0 and 1, when I use the solve command, I will once again choose solve numerically, and I will set the lower and upper bounds on my solution to be 0 and 1 respectively. The ClassPad gives me two solutions. The first one, t equals 0, needs to be excluded, as t is strictly between 0 and 1, and so our answer is 0.27, rounded to 2 decimal places. In Part D, we need to find the time when the difference between f of t and g of t is greatest. A picture of the two functions can help us think about this. You may be able to sketch something like this based on your understanding of linear and exponential functions. Your ClassPad can help with this picture if need be, using a little copy and paste, a view window adjustment, and a cheeky zoom auto. From this, we can see that the difference between the two functions is greatest, either sometime before they intersect or at t equals a third. After t equals a third, the two functions clearly get closer together as the exponential function approaches 22. To find when the difference between f of t and g of t is greatest, I'm going to head back to the main app and consider the absolute value of g of t minus f of t. First, I'll grab the absolute value bars from the Math 1 keyboard, and into them I'm going to drop the input line where I equated g of t and f of t. Now I'll replace that equals sign with a negative, and pop brackets around the f of t part, and it is time to swipe an f max. I'll need to limit my x values to between 0 and a third, and tapping OK, I can see that the time value of interest is 0.12 to 2 decimal places. Part F introduces a piecewise function for heater energy use over time. Part 1 asks us to show that a equals 1.2 e to the 4, given that the functional model p of t is continuous. The continuity of p of t means that at t equals 0.4, 0.3 plus a e to the power of minus 4 equals 1.5. As this is a show that situation, we should include an additional line of working before stating the given result. Something like this, showing the subtraction of 0.3 from both sides, should do the trick. In Part F, Part 2, we are asked how long until the heater has used 0.5 kilowatts. As energy use can be found as the area under the graph of P of t, I'm going to calculate the amount of energy used for the first 0.4 hours by multiplying 0.4 by 1.5. Based on this, the time when the heater has used 0.5 units has to be less than 0.4 and can be found by solving t times 1.5 equals 0.5. This can be solved without the need for any CAS to find that t equals 1/3 hours. The last part of Part F asks us how long until the heater has used 1 kilowatt of energy. As 1 is greater than 0.6, this will involve the exponential decay part of P of t. If the time required is k hours, then the definite integral from 0.4 to k of 0.3 plus 1.2 e to the 4 times e to the negative 10t dt must be equal to 1 take 0.6, which is 0.4, based on the power consumption up to 0.4 hours that was found earlier. This definite integral equation can be solved on our class pad. Giving a value of k equals 1.33 hours to 2 decimal places.